Welcome to the companion podcast of the 5th National Climate Assessment. This bonus episode is an audiobook of NCA5's introductory chapter titled Overview, Understanding Risks, Impacts, and Responses. The overview chapter of NCA5 serves as a summary of a vast amount of assessment and literature covered in the full report. Each statement in the overview is based on evidence provided in the underlying chapters. Listeners are encouraged to dig into those underlying chapters to learn more. For navigation purposes, the episode is split into chapters, corresponding to the 5 major sections of the overview. These sections are Section 1, How the United States is Addressing Climate Change. Section 2, How the United States is Experiencing Climate Change. Section 3, Current and Future Climate Risks to the United States. Section 4, The Choices that will determine the future. And Section 5, How Climate Action can create a more resilient and just nation. Additional information can be found in the show notes or at the NCA5 website, nca2023.globalchange.gov. How the United States is Addressing Climate Change. The effects of human-caused climate change are already far-reaching and worsening across every region of the United States. Rapidly reducing greenhouse gas emissions can limit future warming and associated increases in many risks. Across the country, efforts to adapt to climate change and reduce emissions have expanded since 2018, and U.S. emissions have fallen since peaking in 2007. However, without deeper cuts in global net greenhouse gas emissions and accelerated adaptation efforts, severe climate risks to the United States will continue to grow. Future climate change impacts depend on choices made today. The more the planet warms, the greater the impacts. Without rapid and deep reductions in global greenhouse gas emissions from human activities, the risks of accelerating sea level rise, intensifying extreme weather, and other harmful climate impacts will continue to grow. Each additional increment of warming is expected to lead to more damage and greater economic losses compared to previous increments of warming, while the risk of catastrophic or unforeseen consequences also increases. However, this also means that each increment of warming that the world avoids, through actions that cut emissions or remove carbon dioxide, CO2, from the atmosphere, reduces the risks and harmful impacts of climate change. While there are still uncertainties about how the planet will react to rapid warming, the degree to which climate change will continue to worsen is largely in human hands. In addition to reducing risks to future generations, rapid emissions cuts are expected to have immediate health and economic benefits. At the national scale, the benefits of deep emissions cuts for current and future generations are expected to far outweigh the costs. Box 1.1, Mitigation, Adaptation, and Resilience. Throughout this report, 3 important terms are used to describe the primary options for reducing the risks of climate change. Mitigation, measures to reduce the amount and rate of future climate change by reducing emissions of heat-trapping gases, primarily carbon dioxide, or removing greenhouse gases from the atmosphere. Adaptation, the process of adjusting to an actual or expected environmental change and its effects in a way that seeks to moderate harm or exploit beneficial opportunities. Resilience, the ability to prepare for threats and hazards, adapt to changing conditions, and withstand and recover rapidly from adverse conditions and disruptions. U.S. emissions have decreased, while the economy and population have grown. Annual U.S. greenhouse gas emissions fell 12% between 2005 and 2019. This trend was largely driven by changes in electricity generation. Coal use has declined, while the use of natural gas and renewable technologies has increased, leading to a 40% drop in emissions from the electricity sector. Since 2017, the transportation sector has overtaken electricity generation as the largest emitter. As U.S. emissions have declined from their peak in 2007, the country has also seen sustained reductions in the amount of energy required for a given quantity of economic activity, and the emissions produced per unit of energy consumed. Meanwhile, both population and per capita GDP have continued to grow. Recent growth in the capacities of wind, solar, and battery storage technologies is supported by rapidly falling costs of zero and low carbon energy technologies, which can support even deeper emissions reductions. For example, wind and solar energy costs dropped 70% and 90% respectively over the last decade, while 80% of new generation capacity in 2020 came from renewable sources. Across all sectors, innovation is expanding options for reducing energy demand and increasing energy efficiency, moving to zero and low carbon electricity and fuels, electrifying energy use in buildings and transportation, and adopting practices that protect and improve natural carbon sinks that remove and store CO2 from the atmosphere, such as sustainable agricultural and land management practices. Accelerating advances in adaptation can help reduce rising climate risks. As more people face more severe climate impacts, individuals, organizations, companies, communities, and governments are taking advantage of adaptation opportunities that reduce risks. State climate assessments and online climate services portals are providing communities with location and sector-specific information on climate hazards to support adaptation planning and implementation across the country. New tools, more data, advancements in social and behavioral sciences, and better consideration of practical experiences are facilitating a range of actions. Actions include implementing nature-based solutions, such as restoring coastal wetlands or oyster reefs to reduce shoreline erosion, upgrading stormwater infrastructure to account for heavier rainfall, applying innovative agricultural practices to manage increasing drought risk, assessing climate risks to roads and public transit, managing vegetation to reduce wildlife risk, developing urban heat plans to reduce health risks from extreme heat, planning relocation from high-risk coastal areas. Despite an increase in adaptation actions across the country, current adaptation efforts and investments are insufficient to reduce today's climate-related risks and keep pace with future changes in the climate. Accelerating current efforts and implementing new ones that involve more fundamental shifts in systems and practices can help address current risks and prepare for future impacts. See, mitigation and adaptation actions can result in systemic cascading benefits below. Climate action has increased in every region of the U.S. Efforts to adapt to climate change and reduce net greenhouse gas emissions are underway in every U.S. region and have expanded since 2018. Many actions can achieve both adaptation and mitigation goals. For example, improved forest or land management strategies can both increase carbon storage and protect ecosystems, and expanding renewable energy options can reduce emissions while also improving resilience. Climate adaptation and mitigation efforts involve trade-offs, as climate actions that benefit some or even most people can result in burdens to others. To date, some communities have prioritized equitable and inclusive planning processes that consider the social impacts of these trade-offs and help ensure that affected communities can participate in decision-making. As additional measures are implemented, more widespread consideration of their social impact can help inform decisions around how to distribute the outcomes of investments. Meeting U.S. mitigation targets means reaching net zero emissions. The global warming observed over the industrial era is unequivocally caused by greenhouse gas emissions from human activities, primarily burning fossil fuels. Atmospheric concentrations of carbon dioxide, the primary greenhouse gas produced by human activities, and other greenhouse gases continue to rise due to ongoing global emissions. Stopping global warming would require both reducing emissions of CO2 to net zero and rapid and deep reductions in other greenhouse gases. Net zero CO2 emissions means that CO2 emissions decline to zero or that any residual emissions are balanced by removal from the atmosphere. Once CO2 emissions reach net zero, the global warming driven by CO2 is expected to stop. additional warming over the next few centuries is not necessarily locked in after net CO2 emissions fall to zero. However, global average temperatures are not expected to fall for centuries unless CO2 emissions become net negative, which is when CO2 removal from the atmosphere exceeds CO2 emissions from human activities. Regardless of when or if further warming is avoided, some long-term responses to the temperature changes that have already occurred will continue. These responses include sea level rise, ice sheet losses, and associated disruptions to human health, social systems, and ecosystems. In addition, the ocean will continue to acidify after the world reaches net zero CO2 emissions, as it continues to gradually absorb CO2 in the atmosphere from past emissions. National and international commitments seek to limit global warming to well below 2 degrees Celsius, or 3.6 degrees Fahrenheit, and preferably to 1.5 degrees Celsius, or 2.7 degrees Fahrenheit, compared to pre-industrial temperature conditions, defined as the 1850 to 1900 average. To achieve this, global CO2 emissions would have to reach net zero by around 2050. Global emissions of all greenhouse gases would then have to reach net zero within the following few decades. While U.S. greenhouse gas emissions are falling, the current rate of decline is not sufficient to meet national and international climate commitments and goals. U.S. net greenhouse gas emissions remain substantial and would have to decline by more than 6% per year on average, reaching net zero emissions around mid-century, to meet current national mitigation targets and international temperature goals. By comparison, U.S. greenhouse gas emissions decreased by less than 1% per year on average between 2005 and 2019. Many cost-effective options that are feasible now have the potential to substantially reduce emissions over the next decade. Faster and more widespread deployment of renewable energy and other zero and low-carbon energy options can accelerate the transition to a decarbonized economy and increase the chances of meeting a 2050 national net zero greenhouse gas emissions target for the U.S. However, to reach the U.S. net zero emissions target, additional mitigation options need to be explored and advanced. See, available mitigation strategies can deliver substantial emissions reductions, but additional options are needed to reach net zero below. How the United States is experiencing climate change. As extreme events and other climate hazards intensify, harmful impacts on people across the United States are increasing. Climate impacts, combined with other stressors, are leading to ripple effects across sectors and regions that multiply harms with disproportionate effects on underserved and overburdened communities. Current climate changes are unprecedented over thousands of years. Global greenhouse gas emissions from human activities continue to increase, resulting in rapid warming and other large-scale changes, including rising sea levels, melting ice, ocean warming and acidification, changing rainfall patterns, and shifts in timing of seasonal events. Many of the climate conditions and impacts people are experiencing today are unprecedented for thousands of years. As the world's climate has shifted toward warmer conditions, the frequency and intensity of extreme cold events have declined over much of the U.S., while the frequency, intensity, and duration of extreme heat have increased. Across all regions of the U.S., people are experiencing warming temperatures and longer-lasting heat waves. Over much of the country, nighttime temperatures and winter temperatures have warmed more rapidly than daytime and summer temperatures. Many other extremes, including heavy precipitation, drought, flooding, wildfire, and hurricanes, are becoming more frequent and/or severe, with a cascade of effects in every part of the country. Risks from extreme events are increasing. One of the most direct ways that people experience climate change is through changes in extreme events. Harmful impacts from more frequent and severe extremes are increasing across the country, including increases in heat-related illnesses and death, costlier storm damages, longer droughts that reduce agricultural productivity and strain water systems, and larger, more severe wildfires that threaten homes and degrade air quality. Extreme weather events cause direct economic losses through infrastructure damage, disruptions in labor and public services, and losses in property values. The number and cost of weather-related disasters have increased dramatically over the past 4 decades, in part due to the increasing frequency and intensity of extreme events, and in part due to increases in assets at risk, through population growth, rising property values, and continued development in hazard-prone areas. Low-income communities, communities of color, and tribes and indigenous peoples experience high exposure and vulnerability to extreme events due to both their proximity to hazard-prone areas and lack of adequate infrastructure or disaster management resources. In the 1980s, the country experienced, on average, one inflation-adjusted billion-dollar disaster every 4 months. Now, there is one every 3 weeks on average. Between 2018 and 2022, the U.S. experienced $89 billion events. Extreme events cost the U.S. close to $150 billion each year, a conservative estimate that does not account for loss of life, healthcare-related costs, or damages to ecosystem services. Cascading and compounding impacts increase risks. The impacts and risks of climate change unfold across interacting sectors and regions. For example, wildfire in one region can affect air quality and human health in other regions, depending on where winds transport smoke. Further, climate change impacts interact with other stressors, such as the COVID-19 pandemic, environmental degradation, or socioeconomic stressors like poverty and lack of adequate housing that disproportionately impact overburdened communities. These interactions and interdependencies can lead to cascading impacts and sudden failures. For example, climate-related shocks to the food supply chain have led to local to global impacts on food security and human migration patterns that affect U.S. economic and national security interests. The risk of 2 or more extreme events occurring simultaneously or in quick succession in the same region, known as compound events, is increasing. Climate change is also increasing the risk of multiple extremes occurring simultaneously in different locations that are connected by complex human and natural systems. For instance, simultaneous megafires across multiple western states and record back-to-back Atlantic hurricanes in 2020 caused unprecedented demand on federal emergency response resources. Compound events often have cascading impacts that cause greater harm than individual events. For example, in 2020, record-breaking heat and widespread drought contributed to concurrent destructive wildfires across California, Oregon, and Washington, exposing millions to health hazards and straining firefighting resources. Ongoing drought amplified the record-breaking Pacific Northwest heat wave of June 2021, which was made 2 to 4 degrees Fahrenheit hotter by climate change. The heat wave led to more than 1,400 heat-related deaths, another severe wildfire season, mass die-offs of fishery species important to the region's economy and indigenous communities, and total damages exceeding $38.5 billion in 2022 dollars. Climate change exacerbates inequities. Some communities are at higher risk of negative impacts from climate change due to social and economic inequities caused by ongoing systemic discrimination, exclusion, and under- or disinvestment. Many such communities are also already overburdened by the cumulative effects of adverse environmental, health, economic, or social conditions. Climate change worsens these long-standing inequities, contributing to persistent disparities in the resources needed to prepare for, respond to, and recover from climate impacts. For example, low-income communities and communities of color often lack access to adequate flood infrastructure, green spaces, safe housing, and other resources that help protect people from climate impacts. In some areas, patterns of urban growth have led to the displacement of under-resourced communities to suburban and rural areas with less access to climate-ready housing and infrastructure. Extreme heat can lead to higher rates of illness and death in low-income neighborhoods, which are hotter on average. Neighborhoods that are home to racial minorities and low-income people have the highest inland or riverine flood exposures in the South, and Black communities nationwide are expected to bear a disproportionate share of future flood damages, both coastal and inland. These disproportionate impacts are partly due to exclusionary housing practices, both past and ongoing, that leave underserved communities with less access to heat and flood risk reduction strategies and other economic, health, and social resources. For example, areas that were historically redlined, a practice in which lenders avoided providing services to communities, often based on their racial or ethnic makeup, continue to be deprived of equitable access to environmental amenities, like urban green spaces that reduce exposure to climate impacts. These neighborhoods can be as much as 12 degrees Fahrenheit hotter during a heat wave than nearby wealthier neighborhoods. Harmful impacts will increase in the near term. Even if greenhouse gas emissions fall substantially, the impacts of climate change will continue to intensify over the next decade. See, meeting U.S. mitigation targets means reaching net zero emissions, above, or box 1.4. And all U.S. regions are already experiencing increasingly harmful impacts. Although a few U.S. regions or sectors may experience limited or short-term benefits from climate change, adverse impacts already far outweigh any positive effects and will increasingly eclipse benefits with additional warming. Table 1.2 shows examples of critical impacts expected to affect people in each region between now and 2030. With disproportionate effects on overburdened communities. While these examples affect particular regions in the near term, impacts often cascade through social and ecological systems and across borders, and may lead to longer-term losses. Current and future climate risks to the United States. Climate changes are making it harder to maintain safe homes and healthy families, reliable public services, a sustainable economy, thriving ecosystems, cultures and traditions, and strong communities. Many of the extreme events and harmful impacts that people are already experiencing will worsen as warming increases and new risks emerge. Safe, reliable water supplies are threatened by flooding, drought, and sea level rise. More frequent and intense heavy precipitation events are already evident, particularly in the Northeast and Midwest. Urban and agricultural environments are especially vulnerable to runoff and flooding. Between 1981 and 2016, U.S. corn yield losses from flooding were comparable to that from extreme drought. Runoff and flooding also transport debris and contaminants that can cause harmful algal blooms and pollute drinking water supplies. Communities of color and low-income communities face disproportionate flood risks. Between 1980 and 2022, drought and related heat waves caused approximately $328 billion in damages in 2022 dollars. Recent droughts have strained surface water and groundwater supplies, reduced agricultural productivity, and lowered water levels in major reservoirs, threatening hydropower generation. As higher temperatures increase irrigation demand, increased pumping could endanger groundwater supplies, which are already declining in many major aquifers. Droughts are projected to increase in intensity, duration, and frequency, especially in the Southwest, with implications for surface water and groundwater supplies. Human and natural systems are threatened by rapid shifts between wet and dry periods that make water resources difficult to predict and manage. In coastal environments, dry conditions, sea level rise, and saltwater intrusion endanger groundwater aquifers and stress aquatic ecosystems. Inland, decreasing snowpack alters the volume and timing of stream flow and increases wildfire risk. Small rural water providers that often depend on a single water source or have limited capacity are especially vulnerable. Many options are available to protect water supplies, including reservoir optimization, nature-based solutions, and municipal management systems to conserve and reuse water. Collaboration on flood hazard management at regional scales is particularly important in areas where flood risk is increasing, as cooperation can provide solutions unavailable at local scales. disruptions to food systems are expected to increase. As the climate changes, increased instabilities in U.S. and global food production and distribution systems are projected to make food less available and more expensive. These price increases and disruptions are expected to disproportionately affect the nutrition and health of women, children, older adults, and low-wealth communities. Climate change also disproportionately harms the livelihoods and health of communities that depend on agriculture, fishing, and subsistence lifestyles, including indigenous peoples reliant on traditional food sources. Heat-related stress and death are significantly greater for farm workers than for all U.S. civilian workers. While farmers, ranchers, and fishers have always faced unpredictable weather, climate change heightens risks in many ways. Increasing temperatures, along with changes in precipitation, reduce productivity, yield, and nutritional content of many crops. These changes can introduce disease, disrupt pollination, and result in crop failure, outweighing potential benefits of longer growing seasons and increased CO2 fertilization. Heavy rain and more frequent storms damage crops and property and contaminate water supplies. Longer-lasting droughts and larger wildfires reduce forage production and nutritional quality, diminish water supplies, and increase heat stress on livestock. Increasing water temperatures, invasive aquatic species, harmful algal blooms, and ocean acidification and deoxygenation put fisheries at risk. Fishery collapses can result in large economic losses, as well as loss of cultural identity and ways of life. In response, some farmers and ranchers are adopting innovations, such as agroecological practices, data-driven precision agriculture, and carbon monitoring, to improve resilience, enhance soil carbon storage, and reduce emissions. Across the nation, indigenous food security efforts are helping improve community resilience to climate change while also improving cultural resilience. Some types of aquaculture have the potential to increase climate-smart protein production, human nutrition, and food security, although some communities have raised concerns over issues such as conflict with traditional livelihoods and the introduction of disease or pollution. Homes and property are at risk from sea level rise and more intense extreme events. Homes, property, and critical infrastructure are increasingly exposed to more frequent and intense extreme events, increasing the cost of maintaining a safe and healthy place to live. Development in fire-prone areas and increases in area burned by wildfires have heightened risks of loss of life and property damage in many areas across the U.S. Coastal communities across the country, home to 123 million people, or 40% of the total U.S. population, are exposed to sea level rise, with millions of people at risk of being displaced from their homes by the end of the century. People who regularly struggle to afford energy bills, such as rural, low-income, and older fixed-income households and communities of color, are especially vulnerable to more intense extreme heat events and associated health risks, particularly if they live in homes with poor insulation and inefficient cooling systems. For example, Black Americans are more likely to live in older, less energy-efficient homes and face disproportionate heat-related health risks. Accessible public cooling centers can help protect people who lack adequate air conditioning on hot days. Strategic land use planning in cities, urban greenery, climate-smart building codes, and early warning communication can also help neighborhoods adapt. However, other options at the household scale, such as hardening homes against weather extremes or relocation, may be out of reach for renters and low-income households without assistance. Box 1-2, Migration and Displacement. Extreme events, such as extended drought, wildfire, and major hurricanes, have contributed to human migration and displacement. For example, numerous extreme events over the last 2 decades drove migration of vulnerable communities in Puerto Rico and the U.S. Virgin Islands to the mainland. In the future, the combination of climate change and other factors, such as housing affordability, is expected to increasingly affect migration patterns. More severe wildfires in California, increasing sea level rise in Florida, and more frequent flooding in Texas are expected to displace millions of people. Climate-driven economic changes abroad, including reductions in crop yields, are expected to increase the rate of emigration to the United States. From Alaska to low-lying Pacific atolls, forced migrations and displacements driven by climate change disrupt social networks, decrease housing security, and exacerbate grief, anxiety, and negative mental health outcomes. Indigenous peoples, who have long faced land dispossession due to settler colonialism, are again being confronted with displacement and loss of traditional resources and practices. Infrastructure and services are increasingly damaged and disrupted by extreme weather and sea level rise. Climate change threatens vital infrastructure that moves people and goods, powers homes and businesses, and delivers public services. Many infrastructure systems across the country are at the end of their intended useful life and are not designed to cope with additional stress from climate change. For example, extreme heat causes railways to buckle, severe storms overload drainage systems, and wildfires result in roadway obstruction and debris flows. Risks to energy, water, healthcare, transportation, telecommunications, and waste management systems will continue to rise with further climate change, with many infrastructure systems at risk of failing. In coastal areas, sea level rise threatens permanent inundation of infrastructure, including roadways, railways, ports, tunnels, and bridges, water treatment facilities and power plants, and hospitals, schools, and military bases. More intense storms also disrupt critical services like access to medical care, as seen after Hurricanes Irma and Maria in the U.S. Virgin Islands and Puerto Rico. At the same time, climate change is expected to place multiple demands on infrastructure and public services. For example, higher temperatures and other effects of climate change, such as greater exposure to stormwater or wastewater, will increase demand for healthcare. Continued increases in average temperatures and more intense heat waves will heighten electricity and water demand, while wetter storms and intensified hurricanes will strain wastewater and stormwater management systems. In the Midwest and other regions, aging energy grids are expected to be strained by disruptions and transmission efficiency losses from climate change. Forward-looking designs of infrastructure and services can help build resilience to climate change, offset costs from future damage to transportation and electrical systems, and provide other benefits, including meeting evolving standards to protect public health, safety, and welfare. Mitigation and adaptation activities are advancing from planning stages to deployment in many areas, including improved grid design and workforce training for electrification, building upgrades, and land use choices. Grid managers are gaining experience planning and operating electricity systems with growing shares of renewable generation and working towards understanding the best approaches for dealing with the natural variability of wind and solar sources alongside increases in electrification. Climate change exacerbates existing health challenges and creates new ones. Climate change is already harming human health across the U.S., and impacts are expected to worsen with continued warming. Climate change harms individuals and communities by exposing them to a range of compounding health hazards, including the following: more severe and frequent extreme events, wider distribution of infectious and vector-borne pathogens, air quality worsened by smog, wildfire smoke, dust, and increased pollen, threats to food and water security, and mental and spiritual health stressors. While climate change can harm everyone's health, its impacts exacerbate long-standing disparities that result in inequitable health outcomes for historically marginalized people, including people of color, indigenous peoples, low-income communities, and sexual and gender minorities, as well as older adults, people with disabilities or chronic diseases, outdoor workers, and children. The disproportionate health impacts of climate change compound with similar disparities in other health contexts. For example, climate-related disasters during the COVID-19 pandemic, such as drought along the Colorado River Basin, western wildfires, and Hurricane Laura, disproportionately magnified COVID-19 exposure, transmission, and disease severity and contributed to worsened health conditions for essential workers, older adults, farm workers, low-wealth communities, and communities of color. Large reductions in greenhouse gas emissions are expected to result in widespread health benefits and avoided death or illness that far outweigh the costs of mitigation actions. Improving early warning, surveillance, and communication of health threats, strengthening the resilience of healthcare systems, and supporting community-driven adaptation strategies can reduce inequities in the resources and capabilities needed to adapt as health threats from climate change continue to grow. Box 1-3, Indigenous Ways of Life and Spiritual Health. Indigenous communities, whose ways of life, cultures, intergenerational continuity, and spiritual health are tied to nature and the environment, are experiencing disproportionate health impacts of climate change. Rising temperatures and intensifying extreme events are reducing biodiversity and shifting the ranges of culturally important species like Pacific salmon, wild rice, and moose, making it more difficult for indigenous peoples to fish, hunt, and gather traditional and subsistence resources within tribal jurisdictions. Heat waves can prevent tribal members from participating in traditional ceremonies, while flooding, erosion, landslides, and wildfires increasingly disrupt or damage burial grounds and ceremonial sites. Indigenous peoples are leading numerous actions in response to climate change, including planning and policy initiatives, youth movements, cross-community collaborative efforts, and the expansion of renewable energy. Many of these efforts involve planning processes that start with place-based indigenous knowledge of local climate and ecosystems. Ecosystems are undergoing transformational changes. Together with other stressors, climate change is harming the health and resilience of ecosystems, leading to reductions in biodiversity and ecosystem services. Increasing temperatures continue to shift habitat ranges as species expand into new regions or disappear from unfavorable areas, altering where people can hunt, catch, or gather economically important and traditional food sources. Degradation and extinction of local flora and fauna in vulnerable ecosystems like coral reefs and montane rainforests are expected in the near term, especially where climate changes favor invasive species or increase susceptibility to pests and pathogens. Without significant emissions reductions, rapid shifts in environmental conditions are expected to lead to irreversible ecological transformations by mid to late century. Changes in ocean conditions and extreme events are already transforming coastal, aquatic, and marine ecosystems. Coral reefs are being lost due to warming and ocean acidification, harming important fisheries. Coastal forests are converting to ghost forest, shrublands, and marsh due to sea level rise, reducing coastal protection. Lake and stream habitats are being degraded by warming, heavy rainfall, and invasive species, leading to declines in economically important species. Increased risks to ecosystems are expected with further climate change and other environmental changes, such as habitat fragmentation, pollution, and overfishing. For example, mass fish die-offs from extreme summertime heat are projected to double by mid-century in northern temperate lakes under a very high scenario, RCP 8.5. Continued climate changes are projected to exacerbate runoff and erosion, promote harmful algal blooms, and expand the range of invasive species. While adaptation options to protect fragile ecosystems may be limited, particularly under higher levels of warming, management and restoration measures can reduce stress on ecological systems and build resilience. These measures include migration assistance for vulnerable species and protection of essential habitats, such as establishing wildlife corridors or places where species can avoid heat. Opportunities for nature-based solutions that assist in mitigation exist across the U.S., particularly those focused on protecting existing carbon sinks and increasing carbon storage by natural ecosystems. Climate change slows economic growth, while climate action presents opportunities. With every additional increment of global warming, costly damages are expected to accelerate. For example, 2 degrees Fahrenheit of warming is projected to cause more than twice the economic harm induced by 1 degree Fahrenheit of warming. Damages from additional warming pose significant risks to the U.S. economy at multiple scales and can compound to dampen economic growth. International impacts can disrupt trade, amplify costs along global supply chains, and affect domestic markets. While some economic impacts of climate change are already being felt across the country, the impacts of future changes are projected to be more significant and apparent across the U.S. economy. States, cities, and municipalities confront climate-driven pressures on public budgets and borrowing costs amid spending increases on healthcare and disaster relief. Household consumers faced higher costs for goods and services, like groceries and health insurance premiums, as prices change to reflect both current and projected climate-related damages. Mitigation and adaptation actions present economic opportunities. Public and private measures, such as climate financial risk disclosures, carbon offset credit markets, and investments in green bonds, can avoid economic losses and improve property values, resilience, and equity. However, climate responses are not without risk. As innovation and trade open further investment opportunities in renewable energy, and the country continues to transition away from fossil fuels, loss and disposal costs of stranded capital assets such as coal mines, oil and gas wells, and outdated power plants are expected. Climate solutions designed without input from affected communities can also result in increased vulnerability and cost burden. Many regional economies and livelihoods are threatened by damages to natural resources and intensifying extremes. Climate change is projected to reduce U.S. economic output and labor productivity across many sectors, with effects differing based on local climate and the industries unique to each region. Climate-driven damages to local economies especially disrupt heritage industries, for example, fishing traditions, trades passed down over generations, and cultural heritage-based tourism, and communities whose livelihoods depend on natural resources. As fish stocks in the Northeast move northward and to deeper waters in response to rapidly rising ocean temperatures, important fisheries like scallops, shrimp, and cod are at risk. In Alaska, climate change has already played a role in 18 major fishery disasters that were especially damaging for coastal indigenous peoples, subsistence fishers, and rural communities. While the Southeast and U.S. Caribbean faced high costs from projected labor losses and heat health risks to outdoor workers, small businesses are already confronting higher costs of goods and services and potential closures as they struggle to recover from the effects of compounding extreme weather events. Agricultural losses in the Midwest, including lower corn yields and damages to specialty crops like apples, are linked to rapid shifts between wet and dry conditions, and stresses from climate-induced increases in pests and pathogens. Extreme heat and more intense wildfire and drought in the Southwest are already threatening agricultural worker health, reducing cattle production and damaging wineries. In the Northern Great Plains, agriculture and recreation are expected to see primarily negative effects related to changing temperature and rainfall patterns. By 2070, the southern Great Plains is expected to lose cropland acreage as lands transition to pasture or grassland. Outdoor-dependent industries such as tourism in Hawaii and the U.S.-affiliated Pacific Islands and skiing in the Northwest face significant economic loss from projected rises in park closures and reductions in workforce as continued warming leads to deterioration of coastal ecosystems and shorter winter seasons with less snowfall. Mitigation and adaptation actions taken by businesses and industries promote resilience and offer long-term benefits to employers, employees, and surrounding communities. For example, as commercial fisheries adapt, diversifying harvest and livelihoods can help stabilize income or buffer risk. In addition, regulators and investors are increasingly requiring businesses to disclose climate risks and management strategies. Job opportunities are shifting due to climate change and climate action. Many U.S. households are already feeling the economic impacts of climate change. Climate change is projected to impose a variety of new or higher costs on most households as healthcare, food, insurance, building, and repair costs become more expensive. Compounding climate stressors can increase segregation, income inequality, and reliance on social safety net programs. Quality of life is also threatened by climate change in ways that can be more difficult to quantify, such as increased crime and domestic violence, harm to mental health, reduced happiness, and fewer opportunities for outdoor recreation and play. Climate change, and how the country responds, is expected to alter demand for workers and shift where jobs are available. For example, energy-related livelihoods in the northern and southern Great Plains are expected to shift as the energy sector transforms toward more renewables, low-carbon technologies, and electrification of more sectors of the economy. Losses in fossil fuel-related jobs are projected to be completely offset by greater increases in mitigation-related jobs, as increased demand for renewable energy and low-carbon technologies is expected to lead to long-term expansion in most states' energy and decarbonization workforce. Grid expansion and energy efficiency efforts are already creating new jobs in places like Nevada, Vermont, and Alaska, and advancements in biofuels and agrivoltaics, combined renewable energy and agriculture, provide economic opportunities in rural communities. Additional opportunities include jobs in ecosystem restoration and construction of energy efficient and climate resilient housing and infrastructure. Workforce training and equitable access to clean energy jobs, which have tended to exclude women and people of color, are essential elements of a just transition to a decarbonized economy. Climate change is disrupting cultures, heritages, and traditions. As climate change transforms U.S. landscapes and ecosystems, many deeply rooted community ties, pastimes, traditional knowledges, and cultural or spiritual connections to place are at risk. Cultural heritage, including buildings, monuments, livelihoods, and practices, is threatened by impacts on natural ecosystems and the built environment. Damages to archaeological, cultural, and historical sites further reduce opportunities to transfer important knowledge and identity to future generations. Many outdoor activities and traditions are already being affected by climate change, with overall impacts projected to further hinder recreation, cultural practices, and the ability of communities to maintain local heritage and a sense of place. For example, the prevalence of invasive species and harmful algal blooms is increasing as waters warm, threatening activities like swimming along southeast beaches, boating and fishing for walleye in the Great Lakes, and viewing whooping cranes along the Gulf Coast. In the Northwest, water-based recreation demand is expected to increase in spring and summer months, but reduced water quality and harmful algal blooms are expected to restrict these opportunities. Ranges of culturally important species are shifting as temperatures warm, making them harder to find in areas where indigenous peoples have access. See Box 1.3. Hikers, campers, athletes, and spectators face increasing threats from more severe heat waves, wildfires, and floods, and greater exposure to infectious disease. Nature-based solutions and ecosystem restoration can preserve cultural heritage while also providing valuable local benefits, such as flood protection and new recreational opportunities. Cultural heritage can also play a key role in climate solutions, as incorporating local values, indigenous knowledge, and equity into design and planning can help reaffirm a community's connection to place, strengthen social networks, and build new traditions. The choices that will determine the future. With each additional increment of warming, the consequences of climate change increase. The faster and further the world cuts greenhouse gas emissions, the more future warming will be avoided, increasing the chances of limiting or avoiding harmful impacts to current and future generations. Societal choices drive greenhouse gas emissions. The choices people make on a day-to-day basis, how to power homes and businesses, get around, and produce and use food and other goods, collectively determine the amount of greenhouse gases emitted. Human use of fossil fuels for transportation and energy generation, along with activities like manufacturing and agriculture, has increased atmospheric levels of carbon dioxide, CO2, and other heat-trapping greenhouse gases. Since 1850, CO2 concentrations have increased by almost 50%, methane by more than 156%, and nitrous oxide by 23%, resulting in long-term global warming. The CO2 not removed from the atmosphere by natural sinks lingers for thousands of years. This means that CO2 emitted long ago continues to contribute to climate change today. Because of historical trends, cumulative CO2 emissions from fossil fuels and industry in the US are higher than from any other country. To understand the total contributions of past actions to observed climate change, additional warming from CO2 emissions from land use change, and forestry, as well as emissions of nitrous oxide and the shorter-lived greenhouse gas methane, should also be taken into account. Accounting for all of these factors and emissions from 1850 to 2021, emissions from the U.S. are estimated to comprise approximately 17% of current global warming. Carbon dioxide, along with other greenhouse gases like methane and nitrous oxide, is well mixed in the atmosphere. This means these gases warm the planet regardless of where they were emitted. For the first half of the 20th century, the vast majority of greenhouse gas emissions came from the US and Europe. But as US and European emissions have been falling, US emissions in 2021 were 17% lower than 2005 levels, emissions from the rest of the world, particularly Asia, have been rising rapidly. The choices the US and other countries make now will determine the trajectory of climate change and associated impacts for many generations to come. Box 1-4, Global Warming Levels. Because long-term societal actions are uncertain, climate modeling experts use different scenarios of plausible futures to represent a range of possible trajectories. These scenarios capture variables such as the relationship between human behavior, greenhouse gas emissions, Earth's responses to changes in the concentration of greenhouse gases in our atmosphere and ocean, and the resulting impacts, including temperature change and sea level rise. Since there are uncertainties inherent in all of these factors, especially human behavior and the choices that determine emissions levels, the resulting range of projections are not predictions, but instead reflect multiple potential future pathways. Future climate change under a given scenario is often expressed in one of two ways: as a range of potential outcomes in a future year, or the time at which a specific outcome is expected. Over the next decade, projected global warming is very similar across all scenarios. Updating energy infrastructure or making systemic economic and political changes takes time. Thus, temperature trajectories under different scenarios take time to diverge. By mid-century, 2040 to 2070, differences between projected temperatures under higher and lower scenarios become apparent. By the end of the century, the global warming level, that is, how much the global average surface temperature increases above pre-industrial levels, is expected to exceed 5.4 degrees Fahrenheit or 3 degrees Celsius under high and very high scenarios, SSP 3.7.0 and SSP 5.8.5 respectively. And the world could see more than 7.2 degrees Fahrenheit or 4 degrees Celsius of warming under a very high scenario, SSP 5.8.5. Long-term global warming is expected to stay below 3.6 degrees Fahrenheit or 2 degrees Celsius under a low scenario, SSP 1.2.6, and can be limited to 2.7 degrees Fahrenheit or 1.5 degrees Celsius only under a very low scenario, SSP 1.9. The risk of exceeding a particular global warming level depends on future emissions. This means that projections are conditional. When or if the world reaches a particular level of warming is largely dependent on human choices. Rising global emissions are driving global warming, with faster warming in the US. The observed global warming of about 2 degrees Fahrenheit, or 1.1 degrees Celsius, over the industrial era is unequivocally caused by greenhouse gas emissions from human activities, with only very small effects from natural sources. About 3/4 of total emissions and warming, 1.7 degrees Fahrenheit or around 0.95 degrees Celsius, have occurred since 1970, Warming would have been even greater without the land and ocean carbon sinks, which have absorbed more than half of the CO2 emitted by humans. The US is warming faster than the global average, reflecting a broader global pattern. Land areas are warming faster than the ocean, and higher latitudes are warming faster than lower latitudes. Additional global warming is expected to lead to even greater warming in some US regions, particularly Alaska. Warming increases risks to the US. Rising temperatures lead to many large-scale changes in Earth's climate system, and the consequences increase with warming. Some of these changes can be further amplified through feedback processes at higher levels of warming, increasing the risk of potentially catastrophic outcomes. For example, uncertainty in the stability of ice sheets at high warming levels means that increases in sea level along the continental US of 3 to 7 feet by 2100 and 5 to 12 feet by 2150 are distinct possibilities that cannot be ruled out. The chance of reaching the upper end of these ranges increases as more warming occurs. In addition to warming more, the Earth warms faster in high and very high scenarios, SSP 3.7.0 and SSP 5.8.5 respectively, making adaptation more challenging. How climate action can create a more resilient and just nation. Large near-term cuts in greenhouse gas emissions are achievable through many currently available and cost-effective mitigation options. However, reaching net zero emissions by mid-century cannot be achieved without exploring additional mitigation options. Even if the world decarbonizes rapidly, the nation will continue to face climate impacts and risks. Adequately and equitably addressing these risks involves longer-term inclusive planning, investments in transformative adaptation, and mitigation approaches that consider equity and justice. Available mitigation strategies can deliver substantial emissions reductions, but additional options are needed to reach net zero. Limiting global temperature change to well below 2 degrees Celsius or 3.6 degrees Fahrenheit requires reaching net zero CO2 emissions globally by 2050, and net zero emissions of all greenhouse gases from human activities within the following few decades. See, meeting U.S. mitigation targets means reaching net zero emissions above. Net zero emissions pathways involve widespread implementation of currently available and cost-effective options for reducing emissions alongside rapid expansion of technologies and methods to remove carbon from the atmosphere to balance remaining emissions. However, to reach net zero emissions, additional mitigation options need to be explored. Pathways to net zero involve large-scale technological, infrastructure, land use, and behavioral changes, and shifts in governance structures. Scenarios that reach net zero emissions include some of the following key options. Decarbonizing the electricity sector, primarily through expansion of wind and solar energy supported by energy storage. Transitioning to transportation and heating systems that use zero carbon electricity or low carbon fuels, such as hydrogen. Improving energy efficiency in buildings, appliances, and light and heavy duty vehicles and other transportation modes. Implementing urban planning and building design that reduces energy demands through more public transportation and active transportation and lower cooling demands for buildings. Increasing the efficiency and sustainability of food production, distribution, and consumption. Improving land management to decrease greenhouse gas emissions and increase carbon removal and storage, with options ranging from afforestation, reforestation, and restoring coastal ecosystems to industrial processes that directly capture and store carbon from the air. Due to large declines in technology and deployment costs over the last decade, decarbonizing the electricity sector is expected to be largely driven by rapid growth in renewable energy. Recent legislation is also expected to increase deployment rates of low and zero carbon technology. To reach net zero targets, the U.S. will need to add new electricity generating capacity, mostly wind and solar, faster than ever before. This infrastructure expansion may drastically increase demand for products, batteries, solar photovoltaics, and resources such as metals and critical minerals. Near-term shortages in minerals and metals due to increased demand can be addressed by increased recycling, for example, which can also reduce dependence on imported materials. Most U.S. net zero scenarios require CO2 removal from the atmosphere to balance residual emissions, particularly from sectors where decarbonization is difficult. In these scenarios, nuclear and hydropower capacity are maintained but not greatly expanded. Natural gas-fired generation declines, but more slowly if coupled with carbon capture and storage. Nature-based solutions that restore degraded ecosystems and preserve or enhance carbon storage in natural systems like forests, oceans, and wetlands, as well as agricultural lands, are cost-effective mitigation strategies. For example, with conservation and restoration, marine and coastal ecosystems could capture and store enough atmospheric carbon each year to offset about 3% of global emissions, based on 2019 and 2020 emissions. Many nature-based solutions can provide additional benefits, like improved ecosystem resilience, food production, improved water quality, and recreational opportunities. Adequately addressing climate risks involves transformative adaptation. While adaptation planning and implementation has advanced in the U.S., most adaptation actions to date have been incremental and small in scale. See Table 1.3. In many cases, more transformative adaptation will be necessary to adequately address the risks of current and future climate change. Transformative adaptation involves fundamental shifts in systems, values, and practices, including assessing potential trade-offs, intentionally integrating equity into adaptation processes, and making systemic changes to institutions and norms. While barriers to adaptation remain, many of these can be overcome with financial, cultural, technological, legislative, or institutional changes. Adaptation planning can more effectively reduce climate risk when it identifies not only disparities in how people are affected by climate change, but also the underlying causes of climate vulnerability. Transformative adaptation would involve consideration of both the physical and social drivers of vulnerability and how they interact to shape local experiences of vulnerability and disparities in risk. Examples include understanding how differing levels of access to disaster assistance constrain recovery outcomes, or how disaster damage exacerbates long-term wealth inequality. Effective adaptation, both incremental and transformative, involves developing and investing in new monitoring and evaluation methods to understand the different values of and impacts on diverse individuals and communities. Transformative adaptation would require new and better coordinated governance mechanisms and cooperation across all levels of government, the private sector, and society. A coordinated, systems-based approach can support consideration of risks that cut across multiple sectors and scales, as well as the development of context-specific adaptations. For example, California, Florida, and other states have used informal regional collaborations to develop adaptation strategies tailored to their area. Adaptation measures that are designed and implemented using inclusive, participatory planning approaches and leverage coordinated governance and financing have the greatest potential for long-term benefits, such as improved quality of life and increased economic productivity. Mitigation and adaptation actions can result in systemic cascading benefits. Actions taken now to accelerate net emissions reductions and adapt to ongoing changes can reduce risks to current and future generations. Mitigation and adaptation actions, from international to individual scales, can also result in a range of benefits beyond limiting harmful climate impacts, including some immediate benefits. The benefits of mitigation and proactive adaptation investments are expected to outweigh the costs. Accelerating the deployment of low-carbon technologies, expanding renewable energy, and improving building efficiency can have significant near-term social and economic benefits, like reducing energy costs and creating jobs. Transitioning to a carbon-free, sustainable, and resilient transportation system can lead to improvements in air quality, fewer traffic fatalities, lower costs to travelers, improved mental and physical health, and healthier ecosystems. Reducing emissions of short-lived climate pollutants like methane, black carbon, and ozone provides immediate air quality benefits that save lives and decrease the burden on healthcare systems, while also slowing near-term warming. Green infrastructure and nature-based solutions that accelerate pathways to net zero emissions through restoration and protection of ecological resources can improve water quality, strengthen biodiversity, provide protection from climate hazards like heat extremes or flooding, preserve cultural heritage and traditions, and support more equitable access to environmental amenities. Strategic planning and investment in resilience can reduce the economic impacts of climate change, including costs to households and businesses, risks to markets and supply chains, and potential negative impacts on employment and income, while also providing opportunities for economic gain. Improving cropland management and climate-smart agricultural practices can strengthen the resilience and profitability of farms, while also increasing soil carbon uptake and storage, reducing emissions of nitrous oxide and methane, and enhancing agricultural efficiency and yields. Climate actions that incorporate inclusive and sustained engagement with overburdened and underserved communities in the design, planning, and implementation of evidence-based strategies can also reduce existing disparities and address social injustices. Transformative climate actions can strengthen resilience and advance equity. Fossil fuel-based energy systems have resulted in disproportionate public health burdens on communities of color and/or low-income communities. These same communities are also disproportionately harmed by climate change impacts. A just transition is the process of responding to climate change with transformative actions that address the root causes of climate vulnerability while ensuring equitable access to jobs, affordable low-carbon energy, environmental benefits such as reduced air pollution, and quality of life for all. This involves reducing impacts to overburdened communities, increasing resources to underserved communities, and integrating diverse worldviews, cultures, experiences, and capacities into mitigation and adaptation actions. As the country shifts to low-carbon energy industries, a just transition would include job creation and training for displaced fossil fuel workers and addressing existing racial and gender disparities in energy workforces. For example, Colorado agencies are creating plans to guide the state's transition away from coal, with a focus on economic diversification, job creation, and workforce training for former coal workers. The state's plan also acknowledges a commitment to communities disproportionately impacted by coal power pollution. A just transition would take into account key aspects of environmental justice, recognizing that certain people have borne disparate burdens related to current and historical social injustices and thus may have different needs, ensuring that people interested in and affected by outcomes of decision-making processes are included in those procedures through fair and meaningful engagement, distributing resources and opportunities over time, including access to data and information, so that no single group or set of individuals receives disproportionate benefits or burdens. An equitable and sustainable U.S. response to climate change has the potential to reduce climate impacts while improving well-being, strengthening resilience, benefiting the economy, and, in part, redressing legacies of racism and injustice. Transformative adaptation and the transition to a net zero energy system come with challenges and trade-offs that would need to be considered to avoid exacerbating or creating new social injustices. For example, transforming car-centric transportation systems to emphasize public transit and walkability could increase accessibility for underserved communities and people with limited mobility, if user input and equity are intentionally considered. Equitable responses that assess trade-offs strengthen community resilience and self-determination, often fostering innovative solutions. Engaging communities in identifying challenges and bringing together diverse voices to participate in decision-making allows for more inclusive, effective, and transparent planning processes that account for the structural factors contributing to inequitable climate vulnerability. The NCA5 companion podcast was produced by the U.S. Global Change Research Program. Production by Chris Avery and Allison Crimmins. Chris also served as the narrator for this audiobook. Editing, mixing, and scoring by Mallory Hinks. Thanks to Eliza Lustig, Aaron Grade, Lori Howell, and Mike Cooperberg for their support in developing this series. Thank you also to Ada Limon, the 24th U.S. Poet Laureate, for providing her poetry to this project. The NCA is the U.S. government's premier report on climate change impacts, risks, and adaptation across the nation. It is a congressionally mandated interagency effort that brings together hundreds of experts from federal, state, and local governments, as well as the academic, nonprofit, and private sectors. Information about the NCA5, including the process used to create the assessment, can be found on the NCA5 website at nca2023.globalchange.gov.